Hello dear students, very good morning to all of you. Now we are going to consider the new article from this chapter, that is what is meant by strain energy. There is question for 3 marks, derive an expression for strain energy or derive an expression for the work done when the wire gets elongated. So first of all, what is meant by strain energy? The elastic potential energy gained by the wire during stretching or during elongation of the wire, that is called as the strain energy. As we have studied, when you take a rubber band and when the rubber band is stretched on both the sides, its length changes. The wire gets, or that rubber band gets deformed. So while stretching this rubber band, the elastic potential energy which is gained by this rubber when it gets stretched, that is called as a strain energy. कुठलाही ऑब्जेक्ट आपण स्ट्रेच केला तर त्याचं डिफॉर्मेशन होतं, त्याचे डायमेन्शन्स चेंज होतात. तो जेव्हा स्ट्रेच्ड स्टेटमध्ये असतो तेव्हा त्या ऑब्जेक्टने जी एनर्जी गेन केलेली असते, दॅट एनर्जी इज कॉल्ड ॲज ए स्ट्रेन एनर्जी. वी हॅव टू डिराइव द इक्वेशन फॉर स्ट्रेन एनर्जी. So for that we have considered, since this strain energy we have to derive it, we consider a long and thin uniform wire whose original length is L. The wire is suspended from the rigid support. To the lower end of the wire, we apply some suitable load. That means we apply some suitable mass. Because of this mass, the force acts on this length of the wire, that is equal to mass attached to the wire into the acceleration due to gravity. Because of this force, the wire gets elongated. There is increase in length of the wire. So in the second figure what we have shown, this is the original length of wire L. Because of the application of this load, because of the application of this force, the wire gets elongated, and the extension produced in the wire or increase in length of the wire, that we have denoted by this small L. So up to this there is a original length L. From this the wire gets elongated, so this small L gives us the increasing length of the wire. So from this figure we have said L is the original length of wire, M is the mass attached to the wire, F is the force which is applied to the wire, and L is the extension produced in the wire. Now since here there is increase in length of the material, we can consider which type of stress and strain will get associated with this example. That we know they are tensile stress and tensile strain, किंवा longitudinal stress and longitudinal strain. So if you have to find longitudinal stress, which formula we consider? Longitudinal stress is equal to applied force divided by area of cross section of the material of wire. So applied force is F if area of cross section is A of the material of the wire. If you find the area of cross section, to find it you know the radius of the wire, and if you know the radius of wire, you can find the area of cross section of the wire by considering the formula pi r square. Here it is, we consider simply longitudinal stress is equal to what? Force upon area, applied force upon area. Similarly, longitudinal strain, if you have to find, which formula we consider? It is what? The ratio of increase in length to the original length. Here it is increase in length is L, original length is capital L, so the longitudinal strain comes to be L upon L. Now since here the stress and strain, they are associated for the change in length of the material. To have the change in length of the material, we have considered one elastic constant, and that is known as Young's modulus. So, Young's modulus, it is the ratio of longitudinal किंवा tensile stress to the longitudinal strain किंवा tensile strain. So Young's modulus that we denote by letter this Y, which is equal to longitudinal stress is F upon A, longitudinal strain is L upon L. So it becomes Y is equal to FL divided by AL. So this is what Young's modulus Y is equal to FL upon AL. So rearrange the terms in this equation to write the value for force. So F is equal to YAL divided by L. From this equation what you can say, this applied force depends on this elongation produced in the wire. Means what? What elongation produced in the wire, that depends on the application of force. If the force is less, the elongation or increase in length of the wire is also less. If the force is more, the elongation or increase in length of the wire is also more. So F is directly proportional to L. F is directly proportional to L indicates that this increase in length of wire depends on this force F. But this magnitude of this stretching force do not remain constant, but it goes on changing. Initially, at this stage, the elongation produced in the wire is, suppose we denote by X, it is equal to 0. When we apply some force, then the elongation will get produced in the wire. And if we go on applying the force to the wire, there will be the large extension produced in the wire. So finally, we have said that the elongation produced in the wire is L. Increase in length of the wire is L. So this magnitude of stretching force is not constant throughout the experiment, but it goes on changing. आपल्याला माहिती आहे की आपण ह्या ऑब्जेक्टला थोडा फोर्स अप्लाय केला, थोडी लेंथ इन्क्रीज होईल, अजून फोर्स अप्लाय केला, अजून लेंथ इन्क्रीज होईल. हा फोर्स जे मॅग्निट्यूड आहे ते कॉन्स्टंट नाहीये, ते चेंज होतंय. आणि म्हणून आपण काय कन्सिडर केलं की सुरुवातीला देयर इज नो एक्सटेंशन प्रोड्युस्ड इन द वायर, पण जेव्हा तुम्ही फोर्स अप्लाय करायला लागाल त्यावेळेस एक्सटेंड होत जाईल वायर, पण हे इलॉंगेशन एल जे आहे हे फायनल इलॉंगेशन मिळण्यासाठी फोर्स जो आपण अप्लाय केलाय तो चेंज होत जातो आहे. आणि हा चेंज झाल्यामुळे एक्सटेंशन सुद्धा प्रत्येक स्टेपला चेंज होणार आहे. So instead of considering this increase in length L, we can consider a extension produced by the wire that is equal to X, suppose. For small displacement or for small extension produced in the wire, we can call or we denote it by the letter X. मग X एवढा elongation होण्यासाठी आपण जो फोर्स अप्लाय केलेला आहे तो या फोर्स ऐवजी we can say the force applied to the wire we denote it by F. And for this force, the elongation produced in the wire that we denote by X, or the increase in length of the wire that we denote by X. For further very small extension, X पेक्षा ही small, that we say it is dx. हे small displacement किंवा small elongation किंवा small increase in length होण्यासाठी जो force apply केला जाईल तो सुद्धा खूप स्मॉल असणार आहे. आणि स्मॉल फोर्स आपल्याला माहिती आहे, फोर्स इज डायरेक्टली प्रोपोर्शनल टू एल. स्मॉल फोर्स स्मॉल इलॉंगेशन, लार्ज फोर्स लार्ज इलॉंगेशन. हा स्मॉल फोर्स जेव्हा आपण अप्लाय करू त्या स्मॉल फोर्समुळे स्मॉल डिस्प्लेसमेंट होणार. डिस्प्लेसमेंट होणार म्हणजे स्मॉल इलॉंगेशन होणार. सो वी कॅन से फॉर दिस इक्वेशन दिस फोर्स एफ we can denote it by F is equal to YA. हा L जो आहे that we denote by X divided by L. F is equal to this L is replaced by X. Small extension, small elongation, and for that the small force is needed. F is equal to YAX upon L. But as we have considered here, the magnitude of this force changes continuously. Because of that, we have to integrate this equation with respect to dx, so that we get the total work done, which is done by the wire while stretching it. So as you know, the work done by the wire, or work done, what is the formula for work done? That is equal to what? Force into displacement. हा जनरल फॉर्म्युला आहे फोर्सचा. इथे आपल्याला हे फोर्स इक्वेशन एफ आहे हे माहिती आहे. डिस्प्लेसमेंट जी आहे ती आपण फक्त स्मॉल डिस्प्लेसमेंट कन्सिडर करणार आहोत हियर, दॅट इज dx. आणि ह्या स्मॉल डिस्प्लेसमेंट साठी लागलेला फोर्स पण काय आहे? स्मॉल आहे. सो इट इज वर्क डन इज इक्वल टू एफ फोर्स इंटू dx. dx small elongation. For small elongation, small force is needed, and this work done is also small. The small work done we denote it by dw. So we get this equation, work done during the stretching wire, that is equal to force into displacement, but displacement here we consider it in terms of the elongation. So this formula we get, substitute the value of f from this equation. So dw is equal to, f is equal to what? YAX upon L into what? dx. This is dw, that is small work for small elongation. Is equal to what? YAX upon L into dx. We have to find the total work done during the stretching of wire, because this total work done is gained by this wire during its elongation. When it gets stretched, what amount of elastic energy, elastic energy gained by that wire, that is called it strain energy, and that strain energy we have to find. For that we have to find here a small work done for small elongation produced in the wire, and we write this equation in this form. We have to find the total work done by the wire when it gets elongated to the length L. That means the total increase in length of wire is L. For that, what amount of work is done? To find it, we have to integrate this equation. So work done is equal to integration. आणि हे इंटिग्रेशन किंवा हे इलॉंगेशन जे आहे ते आपल्याला कुठून कुठपर्यंत कन्सिडर करायचं आहे? फ्रॉम x इज इक्वल टू 0 टू x इज इक्वल टू L. त्याच्यामुळे आपण इथे त्याचे लिमिट्स कन्सिडर केले. हे लोअर लिमिट आहे x इज इक्वल टू 0 टू x इज इक्वल टू L. कशाचं इंटिग्रेशन घ्यायचं आहे? ह्या स्मॉल वर्क डनचं घ्यायचं आहे. सो इंटिग्रेशन फ्रॉम 0 टू L ऑफ dw is equal to integration from 0 to L. Substitute the value of dw from this equation, that is YAX upon L into dx. Now see the formula. In this equation, this is Young's modulus. This is the area of cross section of the wire. This is the original length of wire. All these terms are constant, so we can take them outside the integration. YA upon L. Integration from 0 to L. कशाचं राहिले? फक्त x dx. You know how to find the integration of x dx. So work done W is equal to YA upon L. X dx चं integration आहे x square by 2. And it is, we have to consider from 0 to L. 0 is the lower limit, L is the upper limit. From 0 to L. आता ह्या व्हॅल्यूज x ची व्हॅल्यू आपल्याला L आणि x ची व्हॅल्यू 0 अशी सबस्टिट्यूट करायची आहे. यू हॅव टू राईट इट ॲज, पहिल्यांदा x ची व्हॅल्यू L घेतली आपण. यू कॅन गेट दिस इक्वेशन. वर्क डन W इज इक्वल टू YA अपॉन L. x इज इक्वल टू L सबस्टिट्यूट करा. सो यू गेट L स्क्वेअर डिवायडेड बाय 2 मायनस x इज इक्वल टू 0 सबस्टिट्यूट करा, लोअर लिमिट. सो 0चं स्क्वेअर डिवायडेड बाय 2. 0 square upon 2 is 0. So you get this equation. Work done W is equal to YA upon L, L square upon 2. So this equation we write in this way. W is equal to this 2 you can write as it is. 1 by 2 YA. This L will get splitted. we write it as YAL upon L into what? This L. But we know YAL upon L is equal to what? F. That we have said in equation number 1. The force is equal to YAL upon L according to the formula for Young's modulus. So this equation, call this as suppose equation number 2. This equation number 2 becomes work done W is equal to half into YAL upon L is replaced by F into this L as it is. So work done W, we get this formula, that is half into force म्हणजेच काय आहे, load applied to the wire, that we denote by load, and L म्हणजे काय आहे, increase in length of wire, or that also we called extension produced in the wire. To half load into extension, half F into L. This work done by stretching a force, this work done by stretching a force is equal to the energy gained by the wire during its extension, and it is also called as the strain energy. Strain energy, that is the elastic energy gained by the wire during its elongation or during its extension. So this work done, that is stored in the form of energy, and that energy we call it as a strain energy. So we get the formula for strain energy is equal to what? Half load into extension. Strain energy and work done are equal. So what formula we get for work done? The same formula we write for strain energy, and it is equal to half load into extension, or it is equal to half F into L. Now if suppose we have to find the equation for strain energy per unit volume, काय करावं लागेल आपल्याला? Strain energy चे जे इक्वेशन आहे, to that formula we have to divide by the volume of the wire. You can calculate the volume of wire by using the formula area of cross section of the wire into the length of wire. If area of cross section is we denote by capital A, we know the original length of wire is capital L, then the volume of wire becomes A into L. We have to find strain energy per unit volume. So strain energy per unit volume is equal to strain energy's equation, that is half F into L divided by volume, that is A into L. So rearrange the term in this equation. Which equation we get? Strain energy per unit volume is equal to half F upon A into L upon L. So strain energy per unit volume is equal to, we get one formula, that is half as it is F upon A, force upon area. This term gives us what? Stress, and L upon L, this term gives us what? Strain. So one formula we get here for the strain energy per unit volume in terms of stress and strain, and it is half stress into strain. So we get the equation for strain energy per unit volume is equal to half into stress into strain. Question for 3 marks. Derive an expression for strain energy per unit volume for the stretched wire. It is equal to half stress into strain. किंवा क्वेश्चन असतो derive an expression for the work done by the wire. So work done, that is equal to half load into extension. Strain energy is also equal to half load into extension. But if you have to find strain energy per unit volume, you get this formula, half stress into strain. Now here it is we are taking the example which is related to the changes in length of the material, and changes in length of the material is associated with the elastic constant that is known as Young's modulus. So basic ratio for the elastic constant is what? The ratio of stress to strain. For Young's modulus it is what? The ratio for longitudinal stress to the longitudinal strain. So if you get this elastic constant here, since the material is related to the changes in length of that wire, we consider this Young's modulus Y is equal to the ratio of stress to strain. So from this equation, stress you can write as Y into strain, and strain we can write as stress divided by Y. Substitute the value of stress and strain in this equation. Two more equations also we write for the strain energy per unit volume, which are these. First one is strain energy per unit volume is equal to half Y. Stress ची व्हॅल्यू आपण इथे सबस्टिट्यूट केली, that is equal to Y into strain square. Strain energy per unit volume which is equal to half stress square divided by Y. कधी प्रॉब्लेम्स मध्ये आपल्याला प्रॉब्लेम सॉल्व्ह करताना स्ट्रेनची व्हॅल्यू दिलेली असते, यंग्स मॉड्युलस दिलेला असतो आणि वी हॅव टू कॅल्क्युलेट स्ट्रेन एनर्जी पर युनिट व्हॉल्यूम, किंवा कधी ते इन टर्म्स ऑफ स्ट्रेसच्या व्हॅल्यूज दिलेल्या असतात and we have to find the strain energy per unit volume. So whenever we have to solve the problems, you have to rearrange the terms in this equation so that we get the formulae for strain energy per unit volume. This is the article which can be asked for 3 marks.